There is a growing recognition in cell biology research that autophagy, the cellular housekeeping process by which the body identifies, dismantles, and recycles damaged components, is not regulated by a single on-off switch, but by a distributed network of signals that communicate across tissues. What is considerably less appreciated in mainstream health conversations is that traditional fermented foods seem to activate this network through multiple converging pathways simultaneously. Kimchi, sauerkraut, natto, kefir, and miso are not interchangeable for this purpose. Each contributes differently, but together they represent a nutritional category that influences what researchers are beginning to call the gut-liver-brain autophagy axis. The most biochemically specific of these contributions comes from vitamin K2, and natto, the fermented Japanese soybean product, is its most concentrated dietary source by a significant margin, delivering approximately 1,000 micrograms of menaquinone per serving. K2, particularly the -7 Malawian Kwacha's form found in natto, activates autophagy specifically in vascular smooth muscle cells, where it also activates matrix GLA protein to prevent calcium from depositing in arterial walls. This makes K2 unusual among vitamins. It is both an autophagy activator and a direct structural guardian of the vascular system, and it does both jobs through mechanisms that appear to be connected rather than separate. The B-complex contribution from fermented foods is less concentrated than what supplements provide, but it carries a delivery advantage that matters biologically. Fermented foods contain B vitamins in matrices alongside other compounds that influence their absorption. Lactic acid bacteria produce B2, B9, B12 analogs, and other compounds during fermentation. And the gut microbiome created by regular fermented food consumption further influences B vitamin synthesis and absorption downstream. The gut bacteria themselves produce short-chain fatty acids, particularly butyrate, as metabolites of fermentation. And butyrate has documented autophagy-activating properties in intestinal epithelial cells and potentially in the brain through vagal signaling. This is the gut-brain autophagy link that makes fermented food consumption interesting beyond simple probiotic delivery. The practical picture for incorporating fermented foods involves diversity rather than high doses of any single product. 2 to 3 tablespoons of live culture fermented vegetables daily, rotating between kimchi, sauerkraut, and fermented radish alongside a small amount of natto for its exceptional K2 content, and regular kefir or yogurt for diverse bacterial strains, represents a meaningful contribution to autophagy-supportive nutrition that no single supplement category replicates in full. There are 2 warnings worth stating clearly. First, fermented foods are frequently high in sodium. A typical serving of kimchi contains 500 to 700 milligrams. People managing hypertension should account for this in their daily sodium budget rather than consuming fermented foods freely alongside other salty foods. Second, histamine sensitivity, which affects a meaningful minority of people with gut permeability issues or diamine oxidase deficiency, can make fermented foods problematic, producing headaches, flushing, and gastrointestinal symptoms. For these individuals, starting with low-histamine fermented options like fresh yogurt rather than aged, long-fermented products is the sensible approach. Pairing fermented foods with prebiotic fiber sources, onions, garlic, leeks, Jerusalem artichoke, and asparagus, provides the substrate that gut bacteria need to produce the autophagy signaling short-chain fatty acids that represent fermented foods' most indirect but potentially far-reaching contribution to cellular health.